Here's how to draw an acceleration versus time graph. Now, the first thing we're going to want to do when trying to draw an acceleration versus time graph is get the velocity versus time graph, which we've already done in a previous video. The key to drawing acceleration graphs is to remember that acceleration is equal to change in velocity over change in time, which if we remember way back from early algebra is the rise over run, or the slope of a velocity versus time graph. Now, it may seem like a lot of effort to calculate the slope everywhere on a velocity graph, but here are some quick tricks that will save you a lot of time. Let's consider our previous problem where we drew the velocity graph for a dog on a rocket ship. Here we used critical time points to mark when the dog's velocity was changing behavior. Now for an acceleration graph, we're going to use these same critical time points, but look at what the slope is in between each point. If we look between our first two critical time points at t equals 0 and t equals 4, we notice that the slope of our velocity graph is positive and constant. Let's approximate the slope as 4 meters per second squared. So on our acceleration graph, we're going to draw a horizontal line between t equals 0 and t equals 4 seconds at a equals 4. Quick tip. For most physics classes, you will only use horizontal lines for acceleration. That's because acceleration is usually constant. But if acceleration did have a slope, then the change in acceleration over the change in time would be called jerk. But no one likes jerks. Now looking between the next two critical time points at t equals 4 and t equals 6, we see that the slope of the velocity graph is constant and negative. Let's approximate it as negative 8 meters per second squared. So we're going to draw a horizontal line from t equals 4 to t equals 6 at a equals negative 8. You may be wondering why we have two time points at t equals 4, and this is because the slope of the velocity here is technically discontinuous. Here at t equals 4, the slope changes almost instantaneously from a positive slope of positive 4 to a negative slope of negative 8. So don't worry about this. And when doing acceleration graphs, just focus on what's happening to the slope in between the critical time points, rather than what's happening at them. Now looking at the final time points between t equals 6 and t equals 11, we notice that the velocity graph is a horizontal line, so the slope here is a constant 0. This makes sense because our dog was falling to the earth at a constant speed, and so if there's no change in velocity, then there won't be any acceleration. So finishing up, we draw a straight line between t equals 6 and t equals 11 at a equals 0, and you're done. And there you have it. That's how to draw acceleration versus time graph.